So in the last video, I said I was going to derive the gamma term, which is given by the quotient of 1 divided by the square root of 1 minus the squared ratio of the velocity of an object divided by the speed of light. C, which means celeritas, which means fast. So in order for us to do this, we need to, again, physics is all about imagining. So we need to imagine a situation whereby a train or something is moving at a velocity v, and the two people, the primed and the unprimed observer. We want to, let's say in the train, this person inside the train doesn't know he or she is moving, and there's a mirror opposite the train, and there's a flashlight. So the aim of this is to determine the time that the person will measure as the light goes forth and back here. So we want to determine the time this person is going to measure. So let's say the distance from here to here is w. That means the light beam we cover a distance of 2w on going back and forth. So this person, who thinks he or she is stationary inside the train, let's say let's label the time he or she's gonna measure as t sub s, which means t stationary. We want to determine the time he or she's gonna see, this person is gonna see. So we now c is equal to 2w, which is the distance divided by time, while the time he or she's gonna measure, the person is gonna measure, will be given by goes here 2w divided by c. T sub s, which means t sub stationary, is equal to 2w, the distance divided by the velocity. That's what this person measures as the time taken for the light beam to go forth and back to him or her. Now, where the gamma factor comes in is when this person measures the same scenario that this person is measuring. You remember the velocity, the system is moving to the right at the velocity v. We're not assigning any number to it. So this is the system. It's moving to the right at the velocity v. Now, let's do the math. In the triangle, there are three sides: the hypotenuse, the opposite, and the adjacent. Let's say this is side. We're not going to be using any angles, but I just want to bring something to our notion now. We're now sine theta. Let's say this is ABC. Sorry, ABC is equal to the opposite BC is equal to B divided by A. So B is the opposite of the triangle and the basement is the adjacent. So, but that's not the point. The point is to determine what time this person is going to. So the time we're going to give this person, we're going to assign this person is t sub m, which means t sub moving, because he or she is seeing this train moving, so it is t sub m or t sub moving. So we know that this, let's draw it again. It's too wide. Yep, that's it. So we know that the system is moving at a velocity v to the right. Now, according to what someone here will measure, he will see, because the person was formerly here before, so this person is gonna see something happen. He's gonna see this happen. He's gonna see the light going to the right. Yeah, that's what's gonna happen because it's moving at a velocity. Oh shit, moving at a velocity v. So it's gonna see this happen, and the light will come back because it's still moving. It's gonna come back here. So when it's moving this way, this is c, the speed of light. When it's coming back, this is also c. So you have this sort of triangle. So judging by how this is called an isosceles in mathematical terms, it's gonna answer because these two sides are of the same magnitude or the same the same magnitude because this is C. Or yeah, that's what it means because yeah. So uh these two sides are C and C. So the total distance, because this is not going to be distance anymore. It's going to be displacement. So the displacement of the light, it's the resulting vector. So to say, it's going to be the opposite here of this triangle. That's what this person T sub m will measure. So he or she's going to see this. It's going to see. So this is C and this is C. While this is v, the velocity of the train. This is also the velocity of the train. So the displacement of the light beam is simply this part. So we know that c square, let's just find what this, let's say this is x. X square is equal to, sorry, x squared plus v square, according to Pythagorean identity, is equal to c square. X square is equal to c square minus v square, which is the displacement of the light beam. So that x is equal to, this is difference of two squares, but let's leave it like that. Let's not make it more complicated. C square minus v square. Now we can also say that x is equal to the square root c plus v and c minus v, because it's difference of two squares. So that's that for that. So the time measured by this person here is going to be t sub m, or t sub moving, is equal to 2w divided by the displacement, which is given by square root of c square minus v square. So we need to find a way of explicitly writing 2w again. So we know that 2 from the first equation, 2w is equal to c times t sub stationary, t sub s. So if we put that here, we know that t sub m is equal to c times t sub stationary divided by the square root of c squared minus v square. So we know t sub m, t sub moving, is equal to say c times t sub s divided by, let us factorize c out, c squared out, so you have c squared to bracket 1 minus v squared divided by c squared, and we factorize c outside, so we know t sub m is equal to c times t sub s divided by c times the square root of 1 minus v squared divided by c all squared. So c cancels c. So t sub m is equal to ts divided by the square root of 1 minus v squared divided by c squared. This is like writing gamma. So you can say Tm is equal to the gamma or the Lorentz factor. It's very ugly looking. The Lorentz factor times the time as measured by the person inside the system. This is very funny looking. It's a very funny looking gamma. Gamma is more beautiful than that. Oh, jeez. Let me write that again. T sub s. So if you want to make it look more beautiful, you say T sub m, which is the stationary person. And in the last video, we labeled the stationary person as the primed observer. So we know T prime is equal to gamma times the unprimed observer. So this simply explains that someone who is not moving will witness time to be longer in an event than someone who is moving in a system during that event. So that's what relativity is all about. So this is the gamma term. So yeah, that's that for that. Thank you. So my next video will be on probably heat. I'll start with heat and temperature. You build it up, and then math as well. Maybe start from coordinate systems and so on and so forth. Thank you very much.